So hello, everyone. My name's Brian Meacham. I'm running this program for the International Code Council in the United States. Our effort is called Reimagining the ICC Performance Code. And really the aim of this effort is to have a look at performance-based building codes or performance-based building regulations as they're known in some countries, and to see what people are thinking in terms of how performance codes are working or not, how performance design is working or not, and what we might want to do or need to do to make the system more robust in the US. And so at this point, it's a research project. We're looking at different perspectives from a variety of different disciplines. So I've already had roundtable discussions with structural engineers, a group of fire protection engineers, a group of energy and MEP folks. I'll be reaching out and in the process of setting up meetings with building officials and fire officials and architects. And so this group is meant to be people who are more kind of on the side of dealing with facilities, owners, reps, developers and such, because every different group has a few different types of challenges. And so the aim is to really hear from you. So I'm hoping not to do too much speaking after the kind of the kickoff here and kind of hear from you. I've sent around a variety of emailings. I apologize for the volume, but wanted to provide some background to the project so we didn't have to spend too much time on the background today. But again, it's really, I put together a set of questions, just trying to get the sense of where we're at and where you're at and what your concerns are and what you would like to see. And I think that's the focus for today. So just to tell you who I am, some of you know me, but I'm Brian Meacham. I'm consulting for ICC, International Code Council, on this project. I've got over 30 years working in performance-based design for fire, but also performance-based building regulations across a variety of disciplines. I've consulted to a number of countries, as well as working on ICC, the original performance code development, different NFPA committees, and so forth. And so I'm here today mostly as a facilitator and trying to hear from you what your interests are in the performance, where you see opportunities and where you see concerns. So what I'd like to do is I'll kind of walk around the room as I see people and ask for you to give a brief introduction of yourself and who you're with and what you see as your reason to being here, and then we'll kick into the questions. So I think I'll start with Cameron.
Hi, I'm Cameron Osvig. I'm the Director of the Board on Infrastructure and the Constructed Environment at the National Academies of Sciences, Engineering, and Medicine. I'm also the Director of the Federal Facilities Council, which is an association of federal agencies that own and manage real property. What we do is we support the federal government in the management and investment in infrastructure and topics pertaining to those.
Thank you. Christopher Ackerman.
Yes, good morning, everybody. My name is Chris Ackerman. I'm with the Millennium Challenge Corporation, or MCC. We're part of the U.S. government, federal government's foreign international development apparatus, separate from USAID and not part of the State Department, kind of a separate small agency. And I'm sort of our internal lead engineer for buildings and facilities. And I found working with ICC to use the International Performance Code as kind of the code basis for our design standards. We're tricky because we work in low income and lower middle income countries where the capacities are very, very limited. And we find ourselves providing a lot of like hand-holding and assistance with local architects and engineers. But we at MCC feel that we should have, as a matter of policy, a model code as kind of our basis. But we wind up kind of providing a combination of performance and prescriptive guidance to design firms in the work that we fund in poor countries. But thanks for having me.
Great, thank you. Danny Coburn.
Hi, good morning. I'm Dan Coburn. I'm with the Port Authority of New York and New Jersey. I'm the principal fire protection engineering for the mechanical group. We do a lot of work with our facilities, so we interact with a lot of architects and engineers who work on our challenging projects. And from time to time, we have to guide them through the regulations and the requirements. And because a lot of our facilities are existing, this is one area in which we always appreciate, what the performance-based design brings, because it helps us to sometimes get through challenging issues.
Thank you.
Thanks.
Luther Miller.
Yeah, this is Luther Miller. I'm with OBO Design and Engineering, Design Coordination Division, and specifically my colleague and I are the entity that produces OBO design standards, including our OBO codes, which adopt the ICC codes. We do not adopt the performance codes as of yet.
Okay, thank you. Dan Nichols.
Good morning. My name is Dan Nichols. I'm a fire protection engineer, and I'm also the Assistant Vice President of Fire and Code Compliance for the Metropolitan Transportation Authority in New York and Southwest Connecticut. We provide a transportation system for the greater New York area through subways, commuter railroads, bridges, and tunnels. And my office oversees the code compliance, accessibility, and fire safety regulations for infrastructure-based projects that just so happen to also deal with buildings, that mix it together and creates an interesting coupling for us to do designs that are generally performance-based, but stretch the limitations of the prescriptive-based codes that are currently out there. So we really need a succinct tool to keep it moving. So appreciate the invite again, Brian. Thank you.
Thank you. Gary Strong.
Yeah, hi everybody. Thanks, Brian. So I'm Gary Strong. I'm the Global Building Standards Director for the Royal Institution of Chartered Surveyors based in London, UK. I'm also the chair of the International Fire Safety Standards Coalition, which was brought together after the Grenfell Tower fire and has produced the IFSS Common Principles, so the high level principles of fire safety. I'll put the link into the chat box for that as well. So my interest in particular, actually, and thanks for inviting me to this, is ICC are members of the IFSS Coalition, but we do have competing, if you like, on a sliding scale, those who think that there should be a move back to prescriptive standards and those that think that performance-based principles are the way to go. So, my job as chair of the IFSS Coalition can be quite challenging sometimes with those who post the Grenfell Tower fire think that there's a need to get back to more prescriptive regulations as opposed to performance-based. And so there's been some quite interesting discussions around that over the course of the past 4 years. So thanks, Brian.
Thank you. And I have a couple of folks on phone. I think one of them might be David.
David Hammis?
Yep.
Yes, I'm with OBO also, the Bureau of Overseas Buildings Operations of the Department of State. And we, our group, along with Luther, are involved with the standards in criteria for our overseas embassy facilities.
Great. Thank you very much. I think I have everybody at this point. So what I'd like to do is kind of kick it over to any of you that wants to kind of lead in on, just general issue of, what do you think of performance codes and performance design, the way it's working today? And, is it a direction we want to keep going in, or if we want to do it better, what types of things should we be considering to make a more robust approach? Anybody want to
Okay.
jump in?
Well, I'll be the first to step in if you guys don't mind. So given the fact that we are faced with a lot of challenges from our existing buildings, and we have been using performance-based design in areas where we run into challenges. We of course we have some very complex projects that we deal with, and the performance-based approach so far have helped us to get out of areas where it's not very clear in the prescriptive codes. So from my personal opinion, I think it's a good tool to have as the bare minimum. If you can't get clarity on the prescriptive code, it does provide you an avenue in which, based on pure engineering analysis, you can get a way forward in your challenges. So I think from that perspective, I would say that it should remain. We should do what is necessary to make it better, but I think it's a good tool.
Thank you.
This is Luther Miller again. I have a question. How is this different than ICC Building Code Chapter 1, which allows alternate means of compliance?
Yeah, so basically, the way a performance code or a performance regulation is envisioned is that it focuses on essentially what the outcome should be and not how you get there, as compared with, the current IBC, which in 600 or so pages tells you what you should specifically do to get an outcome, but allows you to do an alternative if you're able to appropriately describe or illustrate an equivalency. And part of the challenge is equivalency is often not very well defined. I'll take an example from fire. Is a sprinkler system providing a limit on a fuel load and a 1 hour fire resistant structure equivalent to a 3 hour fire rated structure? And it's always difficult to get kind of an agreement around that, because if you control the fire, then you don't need the resistance. But if the fire is not adequately controlled, what kind of resilience do you want in your structural system? And you have the same type of concern around structural design. You could have it around protective design. So what's your design basis load? What kind of response do you want? And it's really this issue of, are you defining well the performance you want and allowing any appropriate technical means to demonstrate it to be acceptable, versus having a very defined prescriptive route and somebody needing to then decide between alternatives what is appropriate. So if we look at what's in other countries, and Gary could talk to this, in the UK or in England, for example, the regulations are function-based. The regulations are only about 19 pages of functionally oriented requirements. And supporting that is a set of deemed to satisfy documents, which are non-mandatory, called the approved documents, which would be in a way equivalent to the IBC. And you can take that route, but you can also do kind of a first principles engineering analysis following the British standards or other guidance. So it's really our approach in the US is dealing with this big issue of equivalency. How do you determine it? Who determines it? And if the criteria are not in the code, how do you even determine it? Versus a performance-based approach, where if you can well enough to define the function, the performance, and the criteria for measurement, you allow any validated engineering approach to go forward. So it's a bit complex, but it's like coming from top down or bottom up with the aim to get in the same position. But it's sometimes found to be harder demonstrating an equivalency, because equivalent to what is not well defined versus meeting a performance target if you're able to very well define the performance you're expecting.
So we have a, go ahead.
Okay, thanks. Brian, it's Gary. So I was just going to comment on that in terms of the arguments we've had in England over the past 4 years is about the performance-based is you still need to have the flexibility to give the designer that flexibility within those parameters of the performance that the criteria you're setting. If you try and go down a very prescriptive route, such as you should have 2 staircases, you should have sprinklers in every building and whatever, is that the designers are kind of throwing their hands up in horror going, but we can't design to that because we can't meet those very prescriptive requirements. So the system we've currently got, as you described, of the functional requirements of the building regulations with approved documents that give you a kind of guidance as to how you can meet it, or alternatively you can use things like the British standards in terms of performance to meet it and adequately explain it to the building control certifier who's going to sign this off, hopefully, that you're compliant. is kind of where we are still struggling, I think, within England, certainly, as to which way we should go. There's the route of architects, in particular of engineers, who say we need to have it very, very flexible for us to design. And there's a lot of sympathy for that. And there's the others that have said, yeah, but look how it went wrong with Grenfell Tower, and you should have had very prescriptive and very well regulated requirements to stop that thing from happening. So it's a bit of a conundrum. But I think most of the developers, the architects, the engineers that I've spoken to would still favour a performance-based route, provided you've got the adequate criteria and then the checking of the regulatory framework that checks that properly. And I think that's where we've certainly gone wrong in England, is not having that regulatory framework quite right, which is, as you know, is being changed. But so I think there's I've seen over the past 4 years, particularly in England, actually a lot of, like the RIBA, the Royal Institute of British Architects, who were very prescriptive based. Ironically, 30 years ago, they were arguing very much in favour of going performance based and against any prescription, and now they come full circle back the other way. And so they're a little bit of a lone voice actually now, starting to argue still for prescription, very heavy prescription instead of performance-based principles.
Maybe I'll just interject here quickly that the American Institute of Architects has developed a document recently entitled something like Vision 2030, but their intent is that they would like to see everything performance, by 2030. So, there's little commonality around the world in terms of agreement on how to address the way forward, other than trying to get clarity in what we mean by performance, how we measure it, and how we demonstrate it. So I think those are the big challenges. So sorry, Luther, I don't know if that's answered some of your questions.
Yeah, I get it. The types of buildings we design and build require some fairly specific features, and I'm not quite clear on how you would be able to incorporate those, but I'm willing to listen.
Okay.
I think there's an important, the question to the alternate method of materials point in chapter 1. As a code official and as somebody who supervises code officials, we wrestle with the start, alternate methods of materials are great when you want to compare maybe a wood product with a gypsum product, or use a standard material guideline that's already established as the pathway to get there in the construction phase. I like to think about it as alternate materials and methods, because I think it's really a materials-based set of allowances that you find that happen in the construction portion of a project. The performance standard, though, is all about, front loading, or whatever, fancy word you want to use in today's industry, definition phase. It's all happening up there. And what performance standards do is they start to set the benchmarking of, let's have a conversation about what this murky prescriptive section talks about. You want to talk about means of egress, somewhere in that, buried in chapter 10, it should probably say that this thing means get out in 3 minutes less, and you can add 30 seconds for a sprinkler system. That would be nice information to have, but it's not written anywhere. But the performance code allows you to start making those definitions. So when you start talking about small projects, that's not a problem. You start talking about big projects like train station and airports, 4 minutes and get you where, out of the food court. The real question here is, there's this section in the alternate methods and materials, or materials and methods, whatever you want to put it, that it's a paw patch. It's just a way, as far as I'm concerned, as a code official, to be muscled or pressured into taking on something that really the code doesn't allow, but we want to get there anyways. So performance code sets the rules before you start playing the game. That's the way I see it.
Yeah, I mean, I kind of get it. We often have to play defense against some of our other players, I would say. And we had one contractor suggest with a straight face that, well, we require a diplomatic look for our buildings, and we want them to last a certain amount of time, and we require stone on the exterior. The contractor came to us one time and argued that textured paint was just the same thing. So that's, I mean, we get all kinds of funny responses.
Yep. Dan
So-
Coburn.
If I may just add to that statement earlier. So the alternate method, while it's good, it still present a challenge, right? Because it doesn't give you a framework in which to prove that, from an engineering point of view or from a pure analysis point of view, that something will work, right? So even when you say, yes, an alternate method is acceptable, you still need a tool to demonstrate that alternate method, at least to some level of satisfaction, that you can say, well, you have proven it by laying out the framework and demonstrate it, that it will be equivalent, or at least it's another way of doing it. So I don't think even when they say alternate method, it really gives you much of a wiggle room, so to speak. So I think it's still a little bit challenging. Whereas with the performance-based design, as someone alluded earlier, you start right from the top by having the discussion, start the conversation, identify your challenges, and then look at an approach or a solution from an engineering point of view, and then a validation of that approach. I think the validation, because again, you need checks and balances, right? So, you need to have that validation of the engineering approach. And if you get to that point, it doesn't necessarily mean you're all the way there, but it's a good first step.
Yeah, we had an example one time where we have minimum thickness requirements for our stone, and contractor came in with an engineering analysis provided by a licensed professional engineer to say that our thickness was overdone and they could use a much thinner stone, which we were ordered to accept. And then the stone started cracking and falling off the building. So
Yeah, so I'll jump in a little bit again here. I think there's some themes that we're talking around that, you know, have come up quite a bit, and different disciplines approach them a bit differently. So one is having, you know, a clear statement of what is the function you're expecting out of the building, you know, system, feature, or material. The other is, you know, what is the performance expectation around the system or material? And then how do you measure that? So what is the, you know, performance criteria or the performance measure, and then the tool to validate it. So if you're in the energy area and you're looking at, you know, energy use kilowatts per square meter or whatever, and you use a validated energy assessment tool, there seems to be a fairly good agreement that you can go that way. However, there's also the recognition that performance and use doesn't necessarily translate to the performance and the design. So there's performance design for compliance versus, you know, performance and use. And similarly with the structural engineers looking at, you know, earthquake engineering, for example, they're more in the risk-based side in that you're looking at a 50% probability in 20 years of an event occurrence, but having no more damage than an agreeable level. So they have agreed kind of the load, the intensity of the ground motion and the response of the building. And then other disciplines like fire, they haven't agreed what the load is, nor what the resistance of the building is, or the response of the people. So there's this whole spectrum from a clear performance measure with a validated tool that gives an outcome that everybody can pretty well agree with, to the other end of the spectrum where, you know, no part of the equation has actually been agreed, and trying to come to an outcome is a little bit more difficult. So is that, you know, have you seen, and, you know, from your perspectives, that range of, you know, acceptability or problem? Are there particular disciplines that need more work than others? Or, you know, from the different types of facilities, is it, you know, all of the performance measures are just not well enough defined?
I think I would say the latter is that they're not well enough defined in some cases. We have other things that we simply cannot permit anything other than what we need.
Yeah. And I think there's another aspect. This is David Hammes. You know, you look at performance requirements in kind of a situation. You know, like if you're doing things in the U.S. and you have a lot of assumptions about how things are made. When in some of the work we do, we have a lot of constraints there, which are not. There's in some sense a difference between constraints and performance requirements. Are you having to ship this across, things that are not of a concern for most owners and stuff become of an interest to us. You know, how do you handle the materials, you know, on site? And you know, there's a lot of issues. You know, who are the people who are actually going to be installing it? You know, who will be operating it 10 years from now? You know, and those constraints sometimes are not necessarily captured when performance requirements are generated.
Yep. So
Brian, one of the things that we come across is a performance gap. So the actual design performance that's been signed off and built, the building doesn't perform in that way. So there's a lot of work going on in the UK around research around this and trying to measure that gap actually. And why does that gap occur? Is it through just poor construction, you know, too many gaps between components, or you know, just poorly supervised, or even components that have been swapped for other components that are not performing in the way that the original design was designed to do? So there's a lot of concern around the performance gap actually. And I think that's an area where I think sometimes, the performance codes get unnecessarily criticized. Well, the prescriptive brigade would say, well, if you built it in accordance with this very prescriptive requirements, you wouldn't have that performance gap, and therefore by allowing performance codes, etc., you're creeping into this performance gap between the design and the actual as built. So that's an area which is quite a bit of focus for us.
Yeah, I'd like to, we have a couple other folks that haven't spoken much, Cameron, and I think Bernie Denicky joined us, but I'll ask Cameron if you have any thoughts at this point on how the discussion's been going.
So I don't have a lot of knowledge of the codes necessarily. My areas haven't really had much focus in research in those. But what we do, or what from my board, is that broadly, we're looking at an enormous amount of uncertainties in the future, and the prescriptive codes are sort of backward looking, and engineers are designing for an uncertainty and an adaptability, and performance codes are necessary in order to do that. I don't know, or I haven't seen, as you described, any sort of clear performance measures that somebody could say, well, here's the set of performance measures that we're trying to get to, other than, like you described in the seismic sense. And then there's a real risk aversion professionally to performance, to designing using performance standards when the owners are, when there's a potential for a performance gap, or when the owners are looking for low cost, and the prescriptive measures can get you, from a government perspective, they're oftentimes looking for low cost meets requirements.
Yep. Okay.
I agree with that.
Bernie.
Yes, I apologize. I joined the call about 30 minutes late. I was on another meeting. So just to give you a little bit of my background. So I work for the Department of Defense, more specifically the U.S. Navy, and on the facility side of things, where we rely heavily on the International Building Code as kind of the basis for our code, and we try to keep up with that pretty regularly. I'd say we're probably one of the first adopters of the code when it ever comes out, probably way ahead of many of the states to adopt the latest version. We're trying to move to the 2021 code now. And so we talk, sometimes we talk a game of performance requirements in our guide specifications, or, what we're trying to buy. And a lot of times it seems like invariably we run into problems and we get back to a more prescriptive design. We experience problems and we address those problems from, what was originally a performance level type code. And then we start having problems, we get more prescriptive, and we end up with a prescriptive product. So I don't have much experience with performance-based codes. And I think, my initial impression is from listening to the discussion here just over the last few minutes is kind of that performance gap. How do you measure it? What are the measures? And what are you trying to achieve? I see that as a big hurdle, but maybe I'm a little bit naive to the actual subject. That was one of the reasons why I called in. But so it'd be interesting to see where we go. That we, Department of Defense, we're trying to deal with the climate change impacts quite a bit. I think one of the gentlemen here, I think it was Cameron, just mentioned it, that where are we going in the future, and climate's changing. What are the objectives we're trying to meet in the future? How do we define those? That's probably why I think we lean heavily on adopting the latest version of the IBC, because we kind of view that as that's the latest, that's what we should be doing, just to try to keep up with the changes that are occurring. We do get some comfort in doing it, and we've seen it in our facility performance lot of our older facilities. We got a ton of old facilities. They just don't perform well in extreme weather events that we have. And the newer facilities have, traditionally performed better. Hurricane Michael at Tyndall Air Force Base down in Florida, and then Hurricane Florence in the Carolinas. Generally speaking, our newer facilities, performed way better than our older ones. So that would be my perspective. I'm curious with the discussion to learn a little bit more about it. I think we within DoD would have a long way to go before we accepted some performance-based code, just because of the unknown of and having measurable quantities to try to have the designers meet, and then also the construction contractors.
Bernie, hi, this is Dan Coburn again from Report Authority. So in the Navy, like when you have challenges that are beyond the regular code, how do you approach that though? Because sometimes I would assume that there are times when some of the things that you guys want to do doesn't necessarily fit within the ICC. I mean, doesn't fit within the the regular building code of realm, and doesn't that present a challenge? And I'm just curious as to what's the approach when you run into those type of hurdles.
So can you still hear me?
Yes.
Yeah, I can still hear.
Yeah, I'm having a little bit of trouble with my Zoom meeting. Hopefully you can still hear me. Can you still hear me?
Yes.
Yeah. So while I say we rely on the International Building Code quite extensively, I'll use a rough number. I'll say 80% of our requirements are probably covered by the International Building Code and other recognized government standards codes, the IBC, the ASHRAE, NFPA requirements. We rely heavily on those. We do have unique DoD requirements and Department of Defense requirements, and we come up with our own criteria for those particular situations, and we assume the risk. We know there's risk there, but we also know that it's typically driven by a mission requirement by DoD. I'll give you an example.
Mm-hmm.
We refuel some aircraft inside of hangars, and due to a mission requirement, and the code does not allow that. But it's an operational requirement from our clients, the people working in the field, and we just have to say, okay, we recognize the risk. It's part of a mission requirement. If we're going to do it, here's how we're going to try to reduce the risk, and we document that, and we say, okay, if it's a requirement from the client, here's what we're going to do, even though there may be risk involved. So we do have a set of I'll call them DoD unique requirements, where we change the code and we accept something else, but it's typically above the code requirement when we do change stuff. We typically don't go lower, although the example I just gave you there, you could say it's going lower because we're allowing refueling inside the aircraft maintenance hangar, but it's driven by an operational requirement to do that.
Yes, thanks, Bernie. Or at least it's a risk-based approach.
Yeah, I would say typically we look at risk. We may not, quantify it, but we kind of qualify what the risk is. We know the exact number or amount of risk we're taking, but we know.
Mm-hmm. Yeah. So, and the reason why
OBO does a similar thing. We allow certain things based on other requirements, and that's the way we handle it as well.
Mm-hmm.
And right, and so I was just about to say that. So that risk finds itself someplace in performance approach. If Brian, if you just want to expand on that for me, that would be great. But just even by going down the path of risk, which is nothing is wrong with it, it's good, but it does give you, it's moving away from the actual prescriptive methods that are there in the code, and so I think that in itself is taking you into a performance under the performance umbrella.
Yeah, maybe just another kind of quick observations here. When we did the first iteration of the performance code back in the late 90s, we tried very explicitly to build in the concept of tolerable risk. And there's actually a matrix in chapter 3, I believe it is, where we're talking about different magnitude of design events, different performance expectation, and tolerable levels of impact. And that at the time was derived from what the seismic engineers were doing, but also seemed applicable to other hazard events such as fire, where you could, look at the risk levels based on either the use of the occupancy, the magnitude of the hazard impacting it, whether the hazard would cause an unacceptable loss in the building, or if a loss in the building caused an unacceptable impact on the community. And the structural engineers, at least for hazards, have even moved more in that direction. But other areas like fire seem to be hesitant to take on risk-based approaches, which is always a bit of a challenge because there is no absolute safety. So all decisions are risk-based at a certain level, and to a certain extent it's identifying the range of uncertainty and the points of variability, and trying to find what load you should test the building against in what conditions to get an acceptable performance. So the structural engineers are still very keen on going risk-based or risk-informed. It seems more challenging in some other areas, but without trying to inflict too much personal bias, I'm not really sure how we can do performance without tackling the risk issue.
Yeah, so risk is, I'm not a risk expert, but I would say, I'm a structural engineer, that's my background, but I would say the majority of our clients, they're I'll call them operators, military members. They don't understand risk probably like a structural engineer would. Like if you tell them, hey, your certain parts of your building may fail, or the components may fail, they look at that as it might be unacceptable. So the client typically doesn't really understand the risk, what risk they're buying into, and how do you explain that to them is always challenging, because they're going to be risk averse because they don't want to lose mission capability or the facility, really for any reason. And we all kind of know that that's probably an unreasonable expectation. At a certain point, you can't design for everything because you may not be able to afford it. So I think a lot of times risk is not well understood by the client, what they're buying into.
So one thought I had is that if you look at just the general work that the ICC does, and what gets done in updating codes over different editions, a lot of that really is risk focused. It may not be done in a calculated way, but most of the changes are trying to address certain risks and what's acceptable.
Yeah, and I think some of the challenge that we're hoping to address is to make that more explicit in terms of what is it that was considered and how did that go into the risk decision, and what aspects of the outcome are therefore from a risk basis usable when you're looking at alternative design. So none of that guidance or thought processes often makes its way into the IBC, and therefore you lose that basis of decision making when you're looking at kind of determine the tolerable risk issue. So I don't necessarily want to stop this discussion and we can come back to it, but I also wanted to give Chris a chance to weigh in, because he's working more in the low and middle income countries, and it's a different type of challenge dealing with building performance there. So I don't know, Chris, if you had anything you wanted to jump in with at this point.
Yeah, I'm having some network problems. Can you hear me okay, Brian?
Yes, thank you.
Okay, great. Yeah, and we, to be frank, we only recently, as a matter of policy, adopted the International Performance Code as kind of our model code basis for design standards criteria. So we don't have a lot of experience under our belt, but we are struggling, as others have said, with the whole risk cost benefit issue. What what we struggle with a lot is in the context where we work in countries, there often is really no regulatory regime whatsoever. There is not like an AHJ like we see in developed economies, United States and other countries. So we have to be very pragmatic about what's possible. And what we find ourselves doing is, what we're doing now is trying to apply as if we were the designer of record to go through the flow chart and look at performance and cost. And what we find is we're struggling with making judgments about performance and the hazard and the performance level with the constraint of cost. So in my organization, we have our statute, founding statute, requires the Millennium Challenge Corporation to look at cost benefit and a minimum return. So we often we go through this process and it's a bit confounding, but we're concluding that we need to lower the performance level wherever we can, because we're not capturing some of the benefits, but we are capturing the cost. So if we are designing, for instance, a high school in Cote d'Ivoire, the Ivory Coast, and it's prone to extreme rainfall, we're not, when we don't capture the benefits of a higher level of resistance to that hazard, and only the cost, then we tank ourselves. So we're struggling with, I would say, maybe a dimension that's less explicit for other institutional owners, but has to be front and center for us, is how much more cost can I afford to increase performance before I'm making it unaffordable or not economically attractive to have such high performance. And we're struggling as others. In our case, ASCE 7, may not have any wind tables or wind maps for the countries we work in. So we're trying our best. I'll be honest with you. I may want to reach out to our colleagues at the OBO, because we work in foreign countries also, but we're not embassy designers and constructors, and we're working with the local context. But I imagine some colleagues at OBO are struggling with some of these things also. But I'm just sharing, I guess, our early journey on applying a performance code. Once we tried to do it the first time, like step number 1, 2, and 3 on the flowchart or the process, it's turned out to be harder, and it is turning out to provide disincentives to design or have design criteria at a level of performance that I thought we would want to have.
Well, thanks for that. That's interesting. And I've done some work for the World Bank and understand completely the challenges of not having the hazard maps and the risk criteria. And that's, a big part of the World Bank's building regulation for resilience program, is to, try to tackle some of those issues. And performance is important there, but it's also, getting the right level of the regulation to fit the needs of the environment. But I in a way, it's all captured together, because I think, partly we're talking about even, whether it's a high risk, high complex facility that requires something special, you need to understand how to quantify the risks and benefits to be able to, make decisions on the performance that's required. But you also need that at the other end. If it's a high school in the Ivory Coast or Uganda or wherever it is, you need to be able to make those decisions. So we don't really have a structure that lays out not only the performance requirements and the level of performance that will be delivered, but what it's going to cost to deliver that performance, and the capital cost realm, but also the long term. And so, I think for some of the complex facilities, it's easier to absorb some of that cost up front. I think for everybody around the table, we've heard that the existing buildings also are a big problem because they're not as resilient to the event. So if you're trying to make decisions as to how to upgrade the resiliency for the revenue that's available or for the funding that's available, that's a difficult decision without a whole lot of tools in the current, at least the International Code Council family of offerings. And then each entity has to kind of make up their or utilize their own approaches. So that there could be some benefit from more common sets of tools to help with some of those decisions, maybe.
One
Right.
question
The one
I
other
have
thing I'd
is-
like to,
go ahead.
go ahead.
One question I have is to what degree, I've seen performance standards in some cases rely a bit on reference standards. You know, it'll reference ASTM standards, stuff like this. Is that kind of still or seen as an avenue? You know, and if that is, you know, the challenge for us is that, you know, if you're operating all in the U.S. environment, that's a little more straightforward. When you're operating among a lot of different countries, all of a sudden you start getting a lot of different, you know, host country standards involved. And, you know, trying to compare a U.S. standard with a British standard, you know, can be or German standard or something like this can be a challenge.
Yeah, so maybe quickly on that, you know, again, it's my personal perspective, and I'm not speaking for the ICC here, because if they go out down a code development process, the process will decide this. But my view is that if you can adequately lay out the functional requirements, performance objectives, and performance criteria, you should be able to use any means of compliance that delivers on those expectations. So I personally don't see, for example, a significant difference between applying the Eurocodes for structure as opposed to ASCE 7, you know, within an environment where, you know, you have the right information to make that decision. And actually the Eurocodes, you know, for structure probably, you know, give you more in many cases than ASCE 7 does, which is so reliant on some of the hazard maps that, you know, information is less available. But I think it would be, you know, the burden on the designer to demonstrate that whether it's an NFPA or British standards or Eurocode or ASCE 7, why it's appropriate to demonstrate performance in that situation. And so it requires a certain level of knowledge, you know, by the designer and the reviewer that that's appropriate in the circumstance. I see, Gary, you have your hand up.
One example.
Yeah, go ahead, you can respond. Yeah.
The one example I saw is a case where I'm trying to remember which is which, but one of the standards had 3 levels of grade for material, another had 2. And so when you got to the high end and the low end, it was kind of straightforward to what to deal with. But when you got to something, I think it was the US, it had 3 levels. If something was satisfactory, you know, graded in the middle level, but not the bottom level in the U.S. When you went to Britain with only 2 levels, you didn't, you know, if you're at the top end of the bottom, that might be okay in the U.S., but they haven't graded it that way, and so you don't, you know, you're now no longer simply relying on the fact that you met a you know, a British standard. You have to actually go in and get the actual value, you know. So it's not as simple as being able to simply rely on, you know, it meeting a certain standard.
Yeah, I don't mean to say it's not easy. I mean, it can be pretty complicated. And I also think you shouldn't mix and match. I mean, so if you're going to adopt the European standards, you don't just drop in then and say, well, I'll pick NFPA for this or the Australian standard for that, because then you have no sense of how anything works together. But if you're in an area where the, you know, the European standards work and you understand those, and then you're consistent within the framework. And I think that's a problem that
Mm.
I've seen in a lot of, especially the low and middle income countries, is that they mix and match, and then you have no idea what the performance of the building is because, you know, the test standards and the installation standards and all the rest may be, you know, not compatible at all. So Gary, you've had your hand up. I want to get back to you.
Yeah, thanks, Brian. I was just going to comment on that. I think one of the things I've seen is that kind of mix and match actually across some countries where, for example, if you take just one example, you know, British Standard 8414, which is very similar to NFPA 285, but there are differences. There's actually 14 other codes around the world that are similar, but not the same as that one particular one. And what we've seen is developers then choose the weakest code. So they drop in the weakest one, and then they go and choose something else from another country, which is the weakest one, and drop all those in so they can achieve what they want to achieve. And it's kind of like gaming the system, as we call it, which is a really unfortunate thing. I mean, one of the things we are trying to do in the coalition is mapping all the codes actually, so that you can have a bit of a better comparison, because that I don't think is currently done. I think there was some work actually underway by ICC at one point to try and map some of these codes, but it is a difficult problem actually. The other question I was going to ask was about risk. So one thing we're wrestling with on one of the British standards committees right now is about low, medium and high risk and how you define that. And that then differs across countries, differs across Europe, for example, as to what people's understanding of it is. And that's where I think we can get into trouble, because we don't adequately really define risk in a way that sometimes clients understand. You know, as code setters, we probably understand it better, but certainly clients don't understand. So they think, well, medium risk, that's not high risk, then it must be okay. You know, so and that invariably comes down to funding as well. So.
Yeah, I think there's a particular challenge with using qualitative risk metrics that have no definition. You know, I think if risk is going to be used as a basis, it needs to be a lot more explicit in terms of, you know, what it is and how it's estimated. And there are processes for doing that, but it's you know, it's a lot different than how we currently do things, I think, in the, I'll call it the broader commercial market for building regulations. I think more on the government side, and in some regulated areas, you know, for example, if you look at chemical process safety, it's all risk-based, and you have, or nuclear power, it's all risk-based, and you have pretty clear criteria and methodologies. And so if we more generally want to go to risk-informed approaches, I think we need to lay out that information in a similar manner to kind of get everybody on the same page. If not, then it's, you know, no different than 20 different people trying to, you know, come up with a definition of equivalency. It's going to vary from jurisdiction to jurisdiction.
So to your earlier point, Brian, this is one area where there is more work need to be done.
Absolutely. You know, I you know, and that's one of the things, you know, one of the many things we're trying to determine through these discussion processes are where are the problems. So I think, you know, getting a handle on risk and risk cost benefit analyses and decisions, and, you know, should risk be the basis for performance, and if so, how would that work? You know, and we haven't even gotten into issues like how do you, you know, work it from the review side. Do we have the right capabilities on the review and enforcement side of things? What kind of tools and methods would be necessary there? You know, to what extent should peer review be used? You know, structural engineers, you know, for hazards in the US, seismic engineers specifically in California, it's almost, you know, 100% of peer review for any performance-based design. So should that be the case for performance-based design of any complex or high-risk facility? So there's all of these things that, you know, we may want to think about, and getting to the core issues of where we have gaps, why we think we have gaps, what is needed to go forward, I think would help inform, you know, future research efforts, how development of any documents might go, and so forth.
This is Luther Miller again. I have a question for people that have used this before. In the U.S., the traditional delivery method has been design, bid, build, where the architects and engineers are working on behalf of the owner. For most of our projects now, we are required to do design, build, where the contractor is actually the prime and the architects and engineers work for the contractor. And in those two cases, the goals of the architects and engineers are vastly different. When they're, in our experience, when they're working for the owner, they are interested in satisfying the owner. When they're working for the contractor, they're interested in satisfying the contractor, lowest price, etc.
Yep. Anybody, Dan Coburn, Dan Nichols, any experience in that realm?
Where do you want me to start?
I kind of expected I'd get that answer, but
You know, the monster, you know, the from my world as an AHJ, you know, the 800-pound, you know, pick the animal of your choice, in the room is the fact that we have design build projects that the architect and the engineer become almost the designer, the arbiter, and the appellate all in the same language by virtue of contracts that write everybody else out. And when it comes to setting the idea, and I hope this helps Luther from our standpoint, before you put the contract out for the design build contract, and I know we're way down a rabbit hole right now, you have to put all of this information in the design documents up front of what are you willing to accept as baselines and inputs. So as it applies design build to a performance-based project, this is actually the difference. This is actually a really great difference between alternate method materials and performance code. The performance code should be completely vetted, and all of the assumptions need to be figured out before you go out to procurement to go find this designer of record. And your procurement office doesn't want to hear that. Your project leads don't want to hear that. But you know, you have to build the fence before you let everybody out in the field. And that's really where we're at insofar as thinking about performance design in the beginning, because we've been using performance design for better part of 20 years through a very little piece of the world called NFPA 130. And that document shouldn't be construed as a performance document. It's more performance relatively than the international codes, but it's not performance. But even in that, where there's, you can make a choice A, B, or C, everybody wants to know, is it a capital A or a lowercase b? And we're really at the point where design build actually could work very well in the performance-based code as long as it's completely fenced in. So that's my opinion.
Yeah, I think you couldn't have said it better. This is a very challenging area, and this is Dan Coburn. And so what we have done, and at least we have tried to establish, is we do try to get all the criteria up front before we go out to the design build. You're right. Once the architects and engineers get in, they kind of wipe everyone else out. But our antidote to that is to try to make sure that we get all our criteria that we want up front. And when we do that, it doesn't mean the challenges go away, because we see it every day. And I'm going to admit that, yes, it is a struggle, but we usually vet the documents and make sure that we get stuff that's sometimes we get criticized for being above and beyond, but we usually try to make sure the criteria get in. But it is a challenging process, I must admit, because the interests sometimes are different.
So one thing, just listening to the discussion there, that I think needs to be recognized is that we're not looking at a complete dichotomy of either it's 100% performance or 100% prescriptive. We really don't deal with those far ends. It's more, where we are in the middle and where, how far it varies from that point. Any performance that we have is likely to have some prescriptive element and vice versa.
Yeah, and I think that's a good
Right.
point. And, one way I often talk about it is, there really is no difference between a performance-based, regulatory system and a prescriptive-based with alternative methods and materials, because each has or should have, here's what you're intended to achieve for performance of the building, and here's a prescriptive route to comply, and here's where you might use engineering methods to get there. And if you look around the world, it's pretty consistent that at least 85 to 90% of a design on any project will be prescriptive, deemed to satisfy solution, because it's just more financially feasible to do that and not warranted to have any performance analysis. It's that tricky 5 to 10% on high risk or complex projects that require something more. But that also seems to be where we're lacking the most guidance on, well, how do you actually deal with that 5 to 10% of buildings, or 5 to 10% of the building design, where the performance expectation is outside of the normal that you would expect for a, what I would call a cookie cutter building, and you have to do something different. How do you put the bounds around that? And I think, we still struggle with that in all aspects in the US, and I think most countries do as well. And part of it is, if we can't define the performance we're looking for in a way that can be, measured, calculated, estimated, and verified, we can't get there, because then it's completely subjective. But it's hard to get people around the table to be able to sit and define those parameters in a way that everybody can address them. And this other issue there is that, it's not clear to me everyone should be doing performance-based design. And some of our regulatory systems allow almost anybody to do anything. Sometimes if you meet a minimum qualification, doesn't mean you're actually competent in the area. And I think this is a little bit also to Dan Nichols' point about putting the fence around the problem, is if you can't control kind of the competency of the people that are doing the work, you're going to have a problem, I think, in getting the performance outcomes out the other end. And so one question around all of this is, if the performance code, gets redeveloped in the US, should there even be more restrictions around, what is meant as a competent, practitioner in a particular field, and, the abilities to apply, certain levels of engineering analyses to be able to do the work. Because if you're trying to write a document that everybody can use, it's going to be really hard to do a robust performance approach.
Yeah, it's true. This is Luther again. We adopt the ICC codes, but we also allow local codes. There's permutations to that, but we've gone down the licensing of architects and engineers route. And in the US, you're required to have some practical experience, then you're allowed to become licensed. In a lot of the countries we work in, as soon as you graduate from a university, you are deemed to be a fully qualified architect or engineer.
Yep. Gary, you had your hand up.
Yeah, thanks, Brian. I was just going to bring in the perspective that we're wrestling with. I do a lot of work with the UK government, as you know, and this thing about competency is really challenging because in a lot of jurisdictions, and that includes the UK, you don't need to be licensed. Architects, you do. That's the only one. But you could set yourself up tomorrow as an engineer or a fire engineer or a surveyor or whatever, and actually don't have to be licensed to do it. So you're reliant on the professional bodies to then regulate their own members. But what if somebody's not a member of a professional body at all? And how do you regulate their competence? Your competence defined as skills, knowledge, experience, and behaviour. So we're very strong on behaviour, for example, within the RICS, and I know a lot of other bodies have moved that way as well. So it's a challenge in countries where there is no state regulator for for licensing individuals, and therefore you're just reliant on the professional bodies themselves, but you don't have to be a qualified member of a professional body. So that is a challenge, but it maybe is easier in the States where you're licensed in each state to be able to practice.
I think that's true. I also think that it is interesting when we go to the UK, when we built London, for instance, a lot of your requirements were more stringent than ours, and that is what governs, particularly in your energy usage and things like that. But I think back to Gary's point, it's the easy ones are the developed countries. The harder ones are actually the ones around the edges. Just has been said here that, there is no regulation or there are no engineers. This also comes down the stream a little bit more in the people operating our buildings, often are locally employed staff, and the capabilities of the maintenance and operations staff in the UK is vastly different than the people involved in other countries.
Yep, good point. So I see we're just past 15 past the hour and due to wrap up pretty soon. And I appreciate all this good discussion so far. I think there's a lot of issues that have been raised that need to be looked at. Most of them are what I'm hearing in other groups. So on the one hand, consistency is good, but that means the challenges are significant. I guess what I'd like to do before we close out is to do kind of once around the room to have last comments or anything in particular that we haven't touched upon in the discussion today that, I really want to capture and we really need to think about. So maybe I'll kick off with Luther, starting with you.
No, I think we've pretty much hit on our high points, and I probably talked way too much anyway, so I'll pass it back.
Okay, David?
The one point that I would make is that, more than a little of our conversation has been in the international context, but in some ways, I think it would be a simpler one in the U.S. one. So it may be worth exploring, how do you operate these things within the context of U.S. standards and stuff like this simpler approach, before trying to expand too quickly in the international focus.
Great, thanks. Dan Coburn?
Yeah, from my perspective, I think what I would love to actually see is how we could better use this tool when it comes to existing buildings with the challenges. And of course, these buildings are not complying with current codes or they were built, let's say 50, 60 years ago. So even the code then are different. When now you're trying to do changes, and you find yourself with a challenge. So that's probably the one area that I would love to see some more discussion on.
Great, thank you. Dan Nichols. Maybe not still with us. Cameron.
Yeah, I don't have a lot to add to the discussion. I think there's definitely a need or to better describe the risk in application of a performance standard. I know that the industry itself is often described as slow to innovate and adopt new materials, and some of that is a hesitancy to go outside of prescriptive standards. And so performance standards would allow for innovative materials, new building systems, and things to be adopted more quickly. Over.
Thank you. Bernie.
Yeah, so a really good discussion. We do a lot of work, of course, in different countries and some austere environments, contingency environments. It got me thinking a little bit. We do have some requirements that dumb down some of the more stringent requirements we have. So contingency operations, we're willing to take more risk because the duration of the facilities may be less. So, we've got, I would call them their prescriptive codes, but if you look at from the opposite direction, you could kind of say maybe they're performance-based code, because you're recognizing that the performance may not be there, but it's a risk you're willing to accept in the contingency environment or austere environment. So all good discussions. Is there any chance that we as participants can get a copy of the original performance-based code? Brian, are we allowed to take a look at that?
Yeah, I should be able to get you copies. You can look at any of the codes free online. You can't download them, but if you want a downloadable version, I'll certainly try to get those from ICC. I don't think that'll be a problem.
Yeah, I'd like to take a look. One of the gentlemen mentioned the risk, three levels of risk. I'd be curious to see how those are defined in there. It'd be interesting. I really appreciate being able to call in. I've learned a lot already. It seems like a lot of us have some of the same issues we're struggling with.
Yep, pretty universal. All right, I'll check into that on the codes and get back to you on that.
Okay, thank you very much.
Yep. Gary.
Yeah, I was just going to add about adoption, actually. So you can have the most beautiful standard in the world, but how do you get adoption, universal buy-in of the code? And I think that's one of the challenges that I face, and probably many others, is that it's sporadic, it's haphazard in terms of adoption of the code, and you need to have consistency. As you know, I've been banging on about global consistency, but it's like it's a long way off. But even within countries, trying to get, within the USA, say, for example, how do you get that universal adoption of a code? And I think that's one thing that we all need to work hard at, and making sure that everybody is using that code if it's the best code that could be used.
Yep, absolutely. I'll just check one more time. Dan Nichols, if you're there. Okay. Well, I want to thank all of you for participating today. Really good discussion. I may reach out to you again for further discussions if you're interested. And if you're not, just let me know. This process will be going on for a few more months yet. Once I get through the first round of roundtable discussions, I'm hoping to have a workshop, probably first part of the year, where all the different disciplines get together and try to, talk around some of the key items that everyone has identified in common to see if we might look at getting consensus, across the breadth of the stakeholders to see where focus really needs to be put. And, I think structure of the system, the definitions, the risk issue as a basis for performance, existing buildings, there's quite a few themes that are coming in there. So that should be a robust workshop. So hopefully I'll be able to have your participation in the future. And if, no worries if that doesn't work out for you. With that, if there is nothing else, I'd like to call the meeting to a close. Thank you very much for your participation, and I'll be in touch with everyone. Thank you.
Thanks, Brian.
Thanks, Brian. Thanks, everyone. Bye.
Thanks,
Yep.
everyone. Bye-bye.
Bye.